Assalamualaikum. We are from semester 4, NHSI 4, course MRD 446, Applied Anatomy in Radiography. Our lecturer's name is Madam N. Irina. We are from group number 3 with the topic of the relationship of the musculoskeletal system of the shoulder. These are our team members. Let's begin with myself. My name is KAMIL bin RAHMAN, then Muhammad TAHA bin HAMIDON, Muhammad FIKRI bin RASHID, and Muhammad FADLI bin RASHID. Here is our content that we are going to discuss. Number 1, the shoulder anatomy, the muscle attachment to the shoulder bones, the ligaments, and the radiograph, and the conclusion of this presentation. In this slide, I will be showing an anterior part of the shoulder. Shoulder is the most mobile and versatile joint in the human body due to its wide range of motion. But it is also more prone to dislocation than any other joint. It is a ball and socket type of synovial joint. Later I'll be showing you the humerus, more explained on the synovial joint. So the three main parts of the shoulder bones are number 1, clavicle, number 2, scapula, number 3 is humerus. Basically, clavicle is your collarbone, and right to it is a sternum, and the scapular bone joins with the clavicle to form the shoulder girdle, and the scapula located posteriorly, and the humerus or the proximal humerus that connected to the glenoid fossa of the scapula by the head of humerus is located laterally. Later I will explain in detail the bones in the shoulder. The next slide is, what is the clavicle? Clavicle is a long collarbone. It extends horizontally from the manubrium, the upper part of the sternum, to the acromion of the scapula. The clavicle function is to hold the shoulder joint superiorly and laterally from the body trunk. It holds muscle and supports the scapula to allow freedom of movement for the upper limb. Next, what is scapula? Scapula is an irregular and triangular shaped bone, also called shoulder blade. There are two parts to label in the scapula. First one is the coracoid process, and is a piece of bone that sticks out anteriorly and towards the front. And the second one is the acromion, which is wrapped around the laterally, come towards lateral end of the clavicle. And this concave part on the lateral side of the scapula that we have here, we call it glenoid fossa or glenoid cavity. It is a shallow depression that presents along the edge of the lateral angle. This area articulates with the humerus bone to form glenohumeral joint. The scapula has 3 depressions, each called a fossa, or if a plural, you call it fossae. 2 are on the posterior scapula, above and below the scapular spine, and the superior to the spine is the narrow supraspinous fossa, and the inferior to the spine is the broad infraspinous fossa. The scapulas on the anterior side, we call it subscapular fossa, and these fossae are the attachment sites for the muscles that across the shoulder to act on the humerus. And there's a small bump-like projection, the supraglenoid tubercle. It's located above the glenoid cavity, and that be the most easily observed from a lateral view. An indentation called the suprascapular notch appears on the superior border medial to the base of the coracoid process. So now we have the scapula, the coracoid process, the acromion, and glenoid cavity. Next is the humerus. Humerus is the main bone in your arm and have a head on the proximal part and makes it a ball. And this head of the humerus, it articulate with the glenoid cavity and make it like a ball and a socket joint. This ball and socket joint gives the most degrees of freedom and can move arm freely and easily. It can move flexion and extension, adduction, abduction and duction, medial and internal rotation, and circumduction. Because this ball and socket joint allows a lot of extra freedom, but also means need an extra support compared to some of the joints to keep in place by the ligaments. What is synovial joint? It's a type of joint that allows a lot of movement. Example like shoulder, knee, hip, and wrist. And we have an articulate cartilage on the head of humerus, and this articulate cartilage as well in the glenoid fossa or glenoid cavity. So these two surfaces are going to have a smooth articular cartilage and is to reduce the friction with the two bones so they don't wear on each other. Also have synovial fluid between head of humerus and glenoid cavity to sort of like a lubricant to prevent the articulate cartilage to wear down to reduce friction from those two bones. These are the articular surfaces. It primarily covered by hyaline cartilage. It covered the humerus and glenoid cavity of the scapula. It is an attachment capsule where this capsule is a thin and loose to allow a wide range of motion. This capsule attached laterally to anatomical neck of humerus and it extends inferiormedially 1.5 cm to the surgical neck of humerus. From the medial side, this capsule attached to scapula beyond margins of the glenoid cavity.
Assalamualaikum warahmatullahi wabarakatuh and a good day everyone. Before I start my presentations, let me introduce myself. My name is Muhammad TAHA bin HAMIDON. My student ID is 2023475704. So for today, I would like to dive into the fascinating worlds of the shoulder muscles. The shoulder joints, known for its incredible range of motions, is supported and moved by a complex network of muscles. Let's explore these muscles and their roles in shoulder movement and stability. So the shoulder joints or the glenohumeral joints is a ball and socket joints formed by the head of the humerus and the glenoid cavity of the scapula. The muscles around the shoulder provide the strength and the flexibility necessary for the wide range of activity. The muscles of shoulder firstly is a rotator cuff muscles. Rotator cuff muscles is a group of 4 muscles that stabilize the shoulder joints and allow for its wide range of motions. The first is supranucleus muscles located at the top of the shoulder. These muscles help lift the arms away from the body, which is the abductions. So next is the infraspinatus muscle situated on the back of the shoulder, and it allows for the external rotations of arm. Next is the teres minor. You will see the number 3 on the slide. Also on the back, and these muscles assist with the external rotations and adductions, which is the bringing the arm towards the body. The last but not least, the subscapularis are found on the front of the shoulder blade, and it allows for internal rotations of arm. You can see on the slide at the number 4 subscapularis. Yeah, that's all. Okay, next slide is deltoid muscles. Deltoid muscle is the major abductor of shoulder and assists in flexions, extensions, and rotations. So deltoid muscles is the large triangular muscles covering the shoulder, and it has three parts. The first is the anterior deltoid, located at the front, and it held the shoulder flexions, which is the raising arm forwards and internal rotations. The next is the middle deltoid, the number two. So it positions on the side, and it is a primary muscles for shoulder abductions, which is a lifting arm to the side. The lastly is the posterior deltoid, the number three. The posterior deltoid found at the back, and it aids in the shoulder extension, which is the moving the arm backward and the external rotations. Okay, after that we have a pectoralis major, the number three. The pectoralis major is a large and a fan-shaped muscles on the chest, which help shoulder flexions, adductions, and internal rotations. It play a crucial roles in the movement, like pushing and lifting. So number four is the latissimus dorsi. The latissimus dorsi locations on the back, and these broad muscles extend, adduct, and internally rotate the shoulder. It is vital for the movements and such as pulling and rowings. The number five is the bicep brachii. The bicep brachii are located at the front of the upper arm, and two head, a long and a short, that across the shoulder joints. It assists in shoulder flexions and stabilizations. Number six is a tricep brachii. The tricep brachii are located at the backs of upper arm, and has a three head, which is the long lateral and the medial head. The long head across the shoulder joint and aids in a shoulder extension. Okay, now we go for ligaments. The firstly is glenohumeral ligaments. The glenohumeral ligaments are the group of the three ligaments: the superior, the middle, and the inferior of the glenohumeral ligaments. These ligaments are located on the fronts of the shoulder joints and help to stabilize the joints by connecting to the humerus to the glenoid cavity. The superior glenohumeral ligaments, this is the ligament limits external rotations and anterior translations of the humerus. The middle glenohumeral ligaments, this ligament restrict externally rotations, and particularly when the arm is a 45-degree abducted positions. Next, the inferior glenohumeral ligaments. This ligament is the most important stabilizer, especially when the arm is abducted to 90 degrees. It prevents anterior and inferior dislocations. So next is the coracohumeral ligaments, the number two. The coracohumeral ligaments extend from the coracoid process of the scapula of the greater tubercle of the humerus. These ligaments support the superior aspect of the shoulder joints, limit excessive external rotations, and inferior displacements of the humerus. So next, number three is the coracoacromial ligaments. The coracoacromial ligament spans from the coracoid process to the acromion process of the scapula. This ligament form the coracoacromial arch, which act as a protective roof over the head of humerus, prevents superior dislocations. So number four, the transverse humeral ligaments. The transverse humeral ligaments bridge the gap uh, between the greater and the lesser tubercles of the humerus, and it holds the tendons of the long head of bicep brachii muscles in place within the bicipital groove. So the functions and the importance of the ligaments. This ligament collectively positive stability to the shoulder joints, prevents dislocations, the excessive movements that would lead to the injury. They work in harmony with surrounding muscles, tendons, and joint capsule to maintain the integrity of the shoulder joint of the shoulder during the various activity.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad FIKRI bin Abdul Rashid. Okay, this is radiograph of epineutral position of the shoulder. This projection is done by placing the affected arm in neutral position and the palm facing the hip. The shoulder epiview is a standard projection that makes up two shoulder view. The projection demonstrates the shoulder in natural anatomical position, and it will demonstrate the entire clavicle, scapula, as well as glenohumeral, acromioclavicular, sternoclavicular joint of the shoulder girdle. This is radiograph of supraspinatus outlet view. This view demonstrates supraspinatus outlet very well, and this view also oftenly performed instead of lateral shoulder view for the impingement series, such as subacromial impingement. Okay, now let me explain the physiology of muscle contraction of the shoulder. The process of muscle contraction, it begins at the site where a motor neuron terminal meet the muscle fiber, and it is called neuromuscular junction. This is the process of how muscles receive signal from nervous system and it couples the signal to mechanical action and finally contract to produce the movement. Okay, in summary, there is three steps of the muscle contraction of the shoulder. The first one, the excitation. This is where brain send the electrical signal to motor neuron to the shoulder, and then the chemical release, motor neuron release acetylcholine at the neuromuscular junction. And the third one, muscle activation. The acetylcholine binds to receptor on muscle fiber and it generates electrical signal. The second one is excitation contraction coupling. The signal spread, this is where electrical signal travels along the muscle fiber and through the tubules. And then second one is calcium release. The sarcoplasmic reticulum release calcium ions. And the third one binding, the calcium binds to troponin and it moves tropomyosin and expose the binding site on action. And finally, the contraction. This is where contraction happen. The cross bridge formation, the myosin heads attached to actin binding site, and the power stroke, the myosin heads pivot, pulling actin filament and shortening the muscle. And then finally, the cycle repeats where ATP myosin detach reposition and it reattaches to the nerve site of actin. Muscle contraction can be described based on two variables. First one is force, second one is length. We can differentiate force as either tension or load. Muscle tension is the force exerted by the muscle on an object. For example, I'm holding a heavy bottle steady in front of me. My arm muscle create tension to keep the bottle from falling. Second one is load. Load is the force exerted by an object on the muscle. For example, when I carry a backpack, the weight of the backpack is the load exerted on my shoulder muscle. Type of muscle contraction. The first one is isometric contraction. When muscle tension changes, without any corresponding changes in muscle length. For example, I'm holding a bottle steady without moving. The second one is isotonic contraction. This is where the muscle length changes, but muscle tension remains the same. There are two types of isotonic contraction. The first one, concentric contraction, where the muscle shortens as it contracts. For example, lifting a heavy bottle. The second one, eccentric contraction, where muscle lengthens as it contracts. For example, lowering a bottle slowly. Thank you. In natural movement, muscles don't just contract or relax, they constantly adjust their length and tension to adapt to different demands. Continuous changes, the adjustment in the muscle length and tension are not static, they vary continuously over time. And constant adaptation. During locomotor activities, muscles are in a state of constant adaptation. They are always responding to the changing demands of movement. Throughout this process, both the length and the tension of the muscles are continuously adjusting. Thank you.
Everyone. My name is Muhammad FADLI bin Abdul Rashid. My student ID 2023-228-926. Today, I will present the type of rotator cuff muscle, anatomical structure, and how their actions and how muscles acting on the shoulder joint. So the first slide, I will explain the main four rotator cuff muscle. So the first one is supraspinatus muscle. It elevates the shoulder joint out to the sides. The second one is infraspinatus muscle. It externally rotates the shoulder joint. Next, teres minor muscle externally rotates the shoulder joint, while the subscapularis it is allows humerus to move freely during elevation of the arm. Next, I will explain the anatomical structures and their action based on the table shown as the slide. So the first one is infraspinatus muscle. The joint action is it resists posterior dislocation of arm or laterally rotates and abduct arm. Rotator cuff muscle prevent the larger muscles from dislocating the humerus during their action. So the next one is supraspinatus muscle. This aids deltoid in abducting arm. Rotator cuff muscle prevent the larger muscle from dislocating the humerus during their actions. So the next one is subscapularis. It is joint actions medially rotates arm or stabilize shoulder joint. Rotator cuff muscle prevent the larger muscle from dislocating the humerus during their action. Finally, the teres minor. It is laterally rotates and weakly adduct arm. Rotator cuff muscle prevent the larger muscle from dislocating the humerus during their action. Next, we go through the slide of how muscles acting on the shoulder joint. So the scapulohumeral and thoracohumeral muscles are responsible for producing movement at the glenohumeral joint. So the first diagram shows is the flexion movement like this, move forward and the neutral positions. So the prime flexor of the glenohumeral joint are the deltoid, as known as anterior fiber, and pectoralis major is known as clavicular fibers muscles, while coracobrachialis and the long head of bicep brachii assist as weak flexor muscle. Next, the extension position we do like this, from neutral position to the backward. So the extension is performed by the latissimus dorsi, teres major, pectoralis major, as known as sternocostal fibers, and long head of triceps brachii muscle. Of note is that these muscles have a stronger action when acting to extend the flexed arm. Next, we go through the position of the adductions. So the adduction is like this, from this to this. So the adduction is produced by the pectoralis major, latissimus dorsi, and teres major muscle. Together, these three are known as the climbing muscle, as they are powerful adductors. Alternatively, they can lift the trunk up towards a fixed arm. The coracobrachialis, teres minor, short head of biceps, long head of triceps, brachii, and deltoid, as known as posterior fibers muscles, are also active during this movement, depending on the position of the arm. In particular, accessory adductor muscles serve to counter the stronger internal rotation produced by pectoralis major and latissimus dorsi. So next, we go through the movement of abduction like this. So the prime abductors of the arm are the supraspinatus and deltoid muscles. It is believed that the supraspinatus is important for movement initiations and early abduction, while the deltoid muscle is engaged from approximately 20 degrees of abduction and carried the arm through to the full 180 degree of abduction. Contraction of the deltoid muscle applies a strong superior translation force to the humerus. This is countered by the action of the rotator cuff muscle, preventing superior humeral dislocation. Next, we go through the internal rotations. So the internal rotation is positioned like this, in neutral to inwards like this. The internal rotation is primarily performed by the cup, scapularis, and teres major muscles. Pectoralis major, deltoid, as known as anterior fibers, and latissimus dorsi are also capable of producing this movement. The main lateral rotators are the infraspinatus and teres minor muscles with help from the posterior fibers of the deltoid muscles. So we go through the external rotation. So the movement of external rotation is in neutral position to the upwards, like this. The external rotation of the humerus move the greater tubercle out from the under the acromial arch, which allowing an inhibited arm abduction to occur. That's all for my presentation. Thank you.